Welcome everyone to our webinar. Thanks very much for joining. We'll get started now. My name's Gavin Cohen, and what I'll do is I'll go through a brief presentation just to give you an idea of what we mean by autonomous log monitoring and how we can use it to automatically detect and help resolve incidents. And we focus on Kubernetes environments, which is a very interesting use case for this kind of technology. We'll follow that by a demonstration of the technology so you can see it live in action. And then I have a couple of the founders of the company with me in the room, Rod Bagg, VP of Engineering, and Ajay Singh, who's the CEO of the company. And we'll open up a panel for any questions that you might have. If you do have any questions while we're going through the slides or the demo, there's a Q&A function in the Zoom menu. If you choose that and type your questions in, we'll hold the questions till the end and then I'll read them out and go through them. So once again, thanks for joining and we'll get started. So who remembers a time kind of long ago when it was easy to detect when something went wrong with software? Unfortunately, a lot has changed since then. With the complexity that we see today with Kubernetes, microservices, cloud, distributed apps, and the apps themselves becoming more complex, it's getting harder and harder to detect when something goes wrong, let alone to find out what it is. So how do we perform that function today? And it really comes down to some combination typically of log management and monitoring. And unfortunately, this process is almost entirely human driven, where humans manually go through a whole bunch of processes to keep the monitoring and the alerting system working correctly. So let's look at what that means. It starts off with installing an agent, but more difficult than that is building out parsing rules so that you can extract the correct contents of the logs and metrics that you want to monitor and ensure that you pull them in the right way. Once you've done that, you'll build a set of rules that hopefully will alert you when something goes wrong. Now, really, if you think about by definition, the rules that you build will only ever detect things that you know about or know to detect. So usually they're symptoms that you'll detect. For example, you might build a rule to say, alert me when latency goes above a certain threshold. That doesn't tell you why latency went above that threshold. It tells you that something's wrong. So then an incident occurs. And hopefully one of your rules caught it and you're alerted at an appropriate time. But we hear more and more often from customers that they only detect a problem when someone calls in to say something's down or somebody notices that a system isn't working. So one way or another, the incident gets detected and then it's all hands on deck. It's scrambling, it's hunting for the root cause, it's looking at charting some of the metrics, looking in the logs, digging in. And this is sort of a whole process of human effort, intuition, brute force. But if you have a skilled team, hopefully you'll figure out root cause, you'll resolve the incident. And then this process starts to repeat because you then have to go back. And if it hadn't alerted you correctly, you might need to tune or add a new alert rule. You might need to add something to a dashboard to avoid this problem in the future. And the process continues. Then software versions change and you have to go through and make the appropriate changes to your monitoring system. So what does this mean? It's, as I said, human driven, takes a lot of effort from a lot of people. Even when you tune the rules well, we hear too many times everyone's suffering from alarm fatigue, getting too many alerts. And sometimes you get so many alerts that you miss the real problems. And the pain that you go through with the slow time to resolve the incident. Now, as I mentioned before, with today's environments, software becoming more complex, Kubernetes, distributed apps, and so on, the number of possible failure modes has exponentially increased to the point where we fundamentally believe that human-driven monitoring, like I just described, just simply won't scale. And we see it already breaking today. So where's all this going? So at Zebrium, we have a vision. And the vision is built around this notion of what we call autonomous monitoring. And we say autonomous log monitoring because that's where we've started today, but we're doing some interesting things with other components as well. So how does this work? So the idea is all that human-driven effort that I talked about in the previous slide goes away and basically taken over by machine learning. So now we have an auto-deploy agent, takes about 30 seconds to deploy in a Kubernetes environment. It goes out and it discovers all your app logs, container logs, OS logs from all your pods and hosts and clusters and so on. Once that's installed, the log starts streaming, and then the machine learning kicks in. And I'll go through how that works in just a moment. But the notion here is, instead of building manual alert rules, you automatically get alerted when the machine learning detects that something's up. And I'll explain in a moment how that works. So you get detected without having to build rules, which means you can also get alerted on not just known issues, but unknown issues. So things that maybe have never occurred before. Even better than that, part of what is bundled up with an alert are details about the root cause. So the idea here is, instead of being told latency is too high, now go and figure out what went wrong, you'll get an indication of what caused the latency to spike as packaged up inside the alert that should point you to the appropriate log lines to look at to resolve the incident. So this speeds up the whole process. Hopefully you can resolve the incident more quickly than you could have otherwise, without all the sort of scrambling and pain that's normally associated with critical incident resolution. And the net is that that's it. You don't then go back and tune and build anything. The whole thing is self-maintaining. Even as software versions change, logs change, log formats and so on evolve. So as I mentioned, the whole process is automated by machine learning. The alerts are smart. They're not static manual alerts. So they evolve as patterns are detected that are anomalous in a way that indicates an incident. And we massively speed up the mean time to resolve. So in summary, what the technology is doing is really two key things for you: automatically detecting the incidents in the first place, and then automatically telling you and indicating what that root cause is without the pain of searching through millions or billions of events. So with that, I'll go through a little bit about the technology and then jump into a demo, which should really make the whole thing a lot more clear for you. So let me just, from a high level, talk about the principle of what our machine learning is doing. And it goes along the lines that in almost any kind of software application, irrespective of what it is or what it does, or whether it's open source or whether it's your own application, when things go wrong, the patterns in the logs will change. So let me kind of show you what that might look like. So watch carefully the screen and see if you detect anything. Okay, so that was a stream of logs, and something happened where the patterns changed. Now, obviously it was very fast, and I'm guessing no one noticed what happened. So let me play it again and watch carefully. Okay, once again, did anybody notice what happened? And chances are it still went quickly. So let me sort of zoom in on where I stopped it, and you'll see two things happened here. The first is this event, and there was a repeating pattern, occurred for the first time. It had never occurred before, and it actually was the last event on the screen when I stopped it both times. So this is a new event. The other thing that happened, if you were very sharp-eyed, is these two events over here stopped happening. So they were actually happening with constant periodicity. And in fact, that whole sequence that you see above was happening with constant periodicity. And as soon as this new exited message occurred, those two messages stopped. Now, the way the machine learning essentially works is it learns the normal patterns in logs. And when I say logs, I mean all the log streams that we get from all the containers across all the different components of your application. It learns the patterns, and it does so very quickly. And then it knows when things start to become anomalous. So let's go through what that process looks like a little bit. So how does it work? So the log streams come in, and as I mentioned, it's the agent that we use. It's based on open source Fluentd, automatically discovers all the logs from all the different parts of your app and the OS and the Kubernetes logs themselves. They stream in, and from the moment they start streaming in, our machine learning kicks in, and it starts to learn everything about those events. The most important thing it does, and there are multiple phases to this, is it learns the structure of each individual event so that it can then categorize the events. And the reason we do that is, in a typical application, there are millions or billions of log events that are produced every hour. But within those millions or billions, there might only be a few thousand unique types of events. So the idea is we make the problem much more tractable by categorizing each event by its unique event type. And then we have to only learn the patterns of each event type to start to know when things become anomalous. So that's the first part, and that turns out to be the hardest part of the problem. The next part of the machine learning is around anomaly detection of specific event types. So what we now do is we learn the patterns of each event type from the step before. We look for when those patterns change. So when events start for the first time, when they stop, when the periodicity changes, when the frequency changes, when the patterns change of those events, and so on. And then each event, when patterns change, is scored as to how anomalous the pattern change is. And really what we're trying to do is eliminate the sort of random behavior of a lot of events that you would normally see, which is not an indication that anything's going wrong. So that's the first thing we do, is we try and detect individual event types that are anomalous, and we score them. And then the next piece, and this is really the key to getting the signal out of the noise, is we look for cross correlations of high scoring anomalous events across parts of your application, across containers, across pods, across all the different entities. We look for tight correlations that can't be coincidental. And when we see that, that's a really strong indication that something has gone wrong. So what do? We look at what the leading edge of that incident was, and that's typically gives us an indication of root cause. And then we package this up as an incident, and we tell you about it. So we'll send you, for example, a Slack alert automatically that shows you the root cause of the incident, the messages that were sort of at the leading edge of that, and then the symptoms, what happened, which is the rest of the events that were anomalous events that were correlated. And in practice, it's proving to be extremely accurate at completely autonomous incident detection across almost any kind of application. So let me pause there, and I'm going to switch over and show you a demo of what the technology looks like. Okay, so what I have here is an environment which has really a tiny data set. And this is very deliberate for purposes of a demo, because we want to show you just how fast and effective the machine learning is, even with a small data set. So what is the data set that we're using here? It's 24 megs in size, only 180,000 log events. It spans a whole bunch of pods running in an AWS instance of the Atlassian stack. And what we did is we induced an error. We collected the logs from all the different pods using our agents that were auto-collected. And essentially what our machine learning uncovered were, it knows events of error or greater severity. It found some exceptions. It found 154 out of 181,000 events were anomalous. But what was really the important part is this one. It found an incident, meaning a set of anomalies that were tightly correlated in a way where the machine learning believes that an actual incident occurred. So let's click on that and see what it detected. And remember, this is literally, there was no pre-training that took place. No one built a rule in advance. This was just that data set that came in and our machine learning at work on that data set. So what do we see? So on this screen, this is our incident screen. We essentially see, an incident called stopped Postgres database. Okay, so what that is, that's the root cause, or one of the root cause log events that was detected as part of the incident. We show it as sort of the name of the incident. Turns out, to cut a long story short, in this case, it absolutely nailed it. This is actually the root cause of what happened, and I'll show this to you in a moment. If that's enough, and maybe it isn't, but if it is, you can actually, vote on it now. You can say like, meaning it's a good incident. That reinforces our machine learning. You can mute it if it's an incident, it's a good incident, but you don't want to know about it in the future. For example, it might be a known problem and you're already working on it, so you don't want to keep being told there's an incident like this. And if we get it wrong, and we can get it wrong, there are certain things you might perform a software upgrade and we'll start detecting incidents because there are all these new patterns and they're not actual incidents. Then you can click spam, which will both train our machine learning that wasn't an incident, but it'll also prevent you from being notified about those kinds of incidents. But in this case, let's go a little bit further and investigate. So I click on it, and now I'm taken to the bundle of what makes up the incident. So there are two parts. There's the probable root cause, where we see two events. I can expand here, and you can see this comes from a syslog log stream in a particular, PSQL container image, and it's saying, Postgres stopped. And then you see the symptoms, and the symptoms seem to be what happens. And in particular, this one's kind of interesting because here Postgres stopped. Here you're seeing something had trouble connecting, Postgres had trouble from somewhere else connecting. So if we have a look here, turns out this came from a different log stream. The Jira log stream came out from a different pod, from a Jira pod, not from the database pod. So we're seeing this cross correlation of events that is what led to us detecting the incident in the first place. So now there's probably enough there to say this is a good event and I can go ahead and I can like it, but let's keep going and let's look at what else we can uncover. So I'm going to drill down. And what does drill down do? It takes us into our browse tab. And initially we start with this filtered view where we just see the events that make up the incident. Okay, so these are the events that you saw from the previous page, but this time they're sort of shown in time order, and more like you would see in a kind of a log manager view, or if you interleave the logs in a stream. So the two syslog events, some Jira events. Now what can I do? I can go and do some interesting things. Let's say I want to see what else was going on in this particular log stream around it. So what I can do is that there's this little peek function. It's a bit like VIing that individual log stream. It takes me into just that syslog, and you can see those are the two syslog events. This is what happened around it. So I can do whatever troubleshooting I need to do to verify the issue. When I'm done with that, I can clear my peek and I'm taken back to where I was. The other thing I can do is I can say, okay, these events come from two different log sources, but what else happened broadly around it? Now, this is, again, a tiny environment, so not that much was happening, but you might have all kinds of things interleaved, so we can turn this filter off. And what happens here is we stay where we are. So here's the event, but this time you can see there's some Confluence log messages that happened before. There's our syslog events and so on. So you can then start to troubleshoot more. Now, I won't get into all the details. There's a lot of power behind here. You can do all kinds of things and visualize the data in some interesting ways, like in these tracks where we have tracks that show you all the events of error or high severity, or where we uncover exceptions like Java exceptions, Python exceptions, Go exceptions, etc. There's a whole lot we can do, but what I will show you is something interesting. Remember I talked before about the phases of our machine learning, and I said the first thing we do is we learn the event type. So let me just expand that. You can see all the metadata. So in this case, it's an event type. We've actually given it a name, PostgreSQL, and that comes from the fixed text in this event. And then you'll see these blue parts of the event line are actually variables. So what does that mean? That means our machine learning's detected that in this event type, this one that it's categorized as an event type called PostgreSQL, there are actually some variable parts that change between instances of a message. So here we see the golden message. It says Postgres stopped, but stopped itself is a variable in a message of that kind. So let's take a little peek at this. I can chart that variable and see how it changes over time in all the events of this type. And it turns out there are only 3 of them. There's this one that you see at the top, Postgres stopped. This one, a couple of minutes later, sorry, I didn't click on it, which says starting Postgres. That happened 2 minutes later. And then this one, which says, if I can click on it correctly, started Postgres. Okay, so what that says is we've detected the same event type with 3 different values. And if you were to go through and look at what really happened, is Postgres stopped, everything went wrong, all the other applications started complaining, which is the incident we detected. 2 minutes later, somebody started Postgres, which is these 2 messages you see here. And then you see everything come back to normal, and the kind of patterns start to normalize again in the logs. So let me stop there, and I'll just come back to my slide deck just for a moment, and then we'll open up Q&A. But to give you a sense, what we showed you was a single simple log stream that had come in where our machine learning got 180,000 events. It detected an incident in it. So it was literally a needle in the haystack. There were 6 or 7 events out of that 181,000 that it detected as an incident. And in this case, it actually nailed the event. So a lot of people sort of say, well, what kinds of events can you detect? And it turns out that it's pretty ubiquitous, because it's not pre-programmed to look for anything. It's looking for these correlated changes of, pattern that we call anomalies, and correlated sets of anomalous events across different log streams. So we've seen in real life, and this is what kind of a Slack alert might look like that you get when one of these incidents occurs, all kinds of things from app events, Kubernetes events themselves, where there's something goes wrong with a Kubernetes deployment, security events, all kinds of just subtle app bugs. We've got an amazing number of different types of events and interesting stories around events that we've detected that really otherwise would have gone undetected or would have caused an enormous amount of pain. So that ends the formal part of the presentation. What I'd like to do is open it up for Q&A, and I see quite a bit of chat has come through while I've been talking. So I'm going to start to read out the questions, and I have, as I said, with me Ajay Singh, one of the founders and CEO, and Rod Bagg, also a founder and VP of engineering, with me. And I'm going to read out the questions and then have one of those to answer it. So the first question I see here says, I love what I just saw, the demo with logs, but we rely on metrics for monitoring. Do you guys support metrics? So I'm going to, one of you two want to take that one?
Yep, sure. This is Rod Bagg, VP of Engineering here. Yeah, so actually that's a very good and timely question. So we're actually working on metrics and ingesting metrics into the platform as well as logs, because we do understand that a lot of people, today in today's world, we kind of found that people start by monitoring metrics, and when something there goes wrong, they typically dive into the logs to find root cause and so on. So it just makes natural sense for us to be monitoring that as well. So we are adding a collection of metrics from Prometheus to start with. And so we've done some actually really interesting work, some pretty deep engineering design and architecture around building on top of the Prometheus scraper to make it very efficient to send that data back to our platform and to maintain sort of time precision and metadata that's involved in the infrastructure where that data is being collected, so that we can meld those metrics with appropriate log events that are coming from the same sources. This will allow us to do things like stats anomaly analysis and correlate those with log event analysis as well, or log event anomalies, to really form a much higher quality incident with, that's involving both anomalies from those two data sources. So expect that to come out here shortly. We're running it already in our environment where we're collecting those Prometheus stats. We'll also have charting ability within the UI so that you can pick one of those Prometheus stats and see the chart over time. So we're doing lots of great work there. Again, expect that to sort of hit the market here in the next couple of weeks.
Okay, thank you very much, Rod.
Okay.
The next question says, in my previous role, it took a long time to set up the whole log management platform. How does Zebrium make this faster? So I might just take this one just because it's kind of on my screen at the moment, where we're giving you the sign up link. So what I'll do is I'll actually just kind of run you through what the process looks like. The idea is really it's dead simple. Okay, you click on this sign up link, and I just realized you probably can't see my browser, so let me share my browser. That link takes you to the Zebrium sign up page. You basically enter your name and email address. I'm going to say they're Kubernetes, submit. Once you do that, we'll automatically create an account for you. So within about a minute, you'll get login credentials. Once you log in, what happens is, let me go back to my demo screen where I left off before. The moment you log in, the very first screen that you get will look a little bit like this. Okay. So this says log collector setup. So you'll sort of be taken to kind of an initial splash screen that tells you how to install the log collector. So you'll be given a token and a URL, which is how to send your logs to us. But for example, in Kubernetes with Helm 3, you can basically grab that command and just paste it into a shell, just a kube control command, create a namespace, install the log collector with a second one. The only thing you would need to do here to customize, you can see there's this variable. It says your deployment name. You can give it a name so that it's easier to identify. If you leave the default, then your deployment will be called your deployment name, which probably doesn't sound that great, but dead easy. So you paste this into the shell. Within a minute or two, all your logs will they'll start streaming. Machine learning kicks in. And from then on, you'll be able to see the kind of view that you saw before, where we'll learn the patterns, we'll start to detect incidents. What we find is typically, everything will start to show up within a couple of minutes. And most people within an hour will start to see their first incident, because we do collect some of the historical logs that are in your environment. And it'll start to get a little bit more accurate over the following hours. But very quickly, you'll be getting real incident detection and notification. We also can notify you by email or Slack when there is an incident, and it's all nicely bundled up in the UI. So I know I answered in a little bit of a long-winded way, but that's a bit of a glimpse to just how easy, when we say, it takes less than 5 minutes, it really does take less than 5 minutes to get started. Okay, so I'm going to go back to the Q&A, and this one says, can you give some examples of incidents that you've detected? So it's one of you two.
Sure, I'll answer that. So it's diverse set of issues that we've caught in the time we've been in the market with users. Some of them are application bugs. So we have a user that's a workflow automation SaaS company, and I think pretty much the day after they installed us, our machine learning caught a bug that was related to a expiring certificate that nobody had noticed. And if our software hadn't caught it, it would have brought down about 30 production services within a day. And their assessment was it would have taken them hours to fix everything and bring it back online. So we've saved them a lot of headaches. Other examples are we've caught issues in the infrastructure supporting the application. So networking issues or underlying storage issues or issues in the Kubernetes environment itself. Another user, we caught a authentication issue. So this is a Fortune 100 SaaS company with a SaaS application, mission critical. Users that were already logged into the application were fine, but new users were being locked out because of an authentication issue. And they did have APM tools, they had monitoring tools, but it took them 6 hours to detect this problem, and really it took users calling in to support and complaining before they realized they had a problem. And it took a few more hours to get to root cause. At that time, they weren't relying on us, they just were trying us, and we caught the issue within seconds. Finally, we routinely catch security incidents. So we haven't predefined any rules for intrusion or hacking attempts, but some of our users had public ports, and we caught hacking attempts from South America, from East Asia. Just you can imagine the kinds of patterns: someone trying to log in and being repeatedly denied, and eventually getting locked out. That's the kind of thing our software doesn't need a predefined rule for. It automatically catches that because it's a very unusual pattern of events. So hopefully that gives you an idea. It's everywhere from application bugs, infrastructure issues, security issues. We've seen the whole gamut.
Thank you, Ajay. I've got another question that just came in. Do you support search?
So yeah, it's Rod again. So I can take that one. So we do support full regex search capabilities within the UI that Gavin demonstrated. We have a little command bar at the bottom of the screen in the browser window where you're looking at your logs, where you can do full regex searching. I guess our point of view on that is a little bit different, and you probably sort of have already seen this demonstrated, and that is, with us detecting these anomalies and coalescing them up into an incident, what we're really trying to do is pinpoint, what's gone wrong and what the root cause is, and take you to that set of events around that incident, so that we're trying to eliminate the need for you having to hunt and peck around through, the typical search that you might be used to doing with other log managers and so on. And we do that for the obvious reasons of that it's a lot more efficient if we can point you to the right thing right off the bat, and hopefully even call out the correct root cause for you. There's other capabilities that Gavin alluded to with these tracks or heat map kind of display that you see at the top of the browser screen, which allows you to really see any type of event that is occurring and its frequency over time, and whether patterns are changing, where either periodicity and so on in those tracks. So there's lots of capabilities that are extremely efficient when you're dealing with parsed information that's in a database, where you can really graph and plot or find very specific events very efficiently. So we don't call that search. I mean, that's something altogether different than what you might be used to with search. And again, that's just because we're in a database. We can be very efficient with that. So I guess to summarize, we do support search. We're hoping that it's not something you have to use very often, because there's much more efficient things that we're doing for you that hopefully you're taking advantage of.
Cool. Thank you very much, Rod. And just kind of last call for questions. I've only got one more in the queue now, which I'll ask in a second. If anybody does have questions, please type them in quickly. But otherwise we'll end off with this one. what platforms do you support?
I can grab that one. And I think, you know, again, you might have seen it on the screen when Gavin was showing the sign up process. So, you know, we obviously support Kubernetes, which is kind of the one that he went into some detail on when he showed you that sign up process. But we also have Linux, where we support a FluentD based collector installed in your Linux environment. We also support CloudWatch for AWS logs that you may have registered with CloudWatch. So there's a little hook in there where you can send those logs to us as well. And then finally, just containers in general. So in that FluentD collector, that can also be installed in a manner where it's detecting your containers and sending those logs to us.
Plus, we have an API, CLI that you can use programmatically to send us log events as well.
Yeah.
Okay, well, look, I'd like to thank Rod and Ajay for jumping in there, and thank everybody for attending. Really appreciate it. We'd love anybody to sign up. It is completely free to sign up at the moment for up to 500 megs of ingest a day. And we look forward to getting feedback. Thank you very much for joining. Bye-bye.